Dr. Vijay Lakshmi is working as a professor in the Department of ECE, Anna University, Chennai. She has more than 17 years of experience in teaching. She has published more than 90 papers in international and national journals and conferences. She has organized more than 10 workshops and has attended more than 40 workshops and seminars. She has guided more than 100 projects in both UG and PG level. She is supervising 14 research scholars. She has established an AICTE-sponsored MODROB project for VLSI Lab. She has an endowment award for the top rank holder in PG degree and has 4 cash awards for producing cent percentage of result in Anna University curriculum. She is a life member in various professional bodies like ISTE and IETE. She has specialized in mobile communication, microprocessor and microcontroller, digital system, computer networking, and neural networks.
Welcome to UGC lecture series, BSc Electronics Honors, Electronics Practicals 9, 8085 Microprocessor Programming. In today's episode, we will discuss about Fibonacci series. This is one of the interesting series which more frequently we are using. Before writing the program, we will discuss how to generate the series. So, in the series, we have only two numbers, that is 0 and 1 is initialized first. Then the sum of the two numbers will be generated. That is the concept in the Fibonacci series. How we are generating the series means the current value is added with the previous value. Now, we will discuss the generation of Fibonacci series. First, I will initialize the value 0 and 1. The first two numbers only initialized. Then these two numbers are added 0 plus 1. The sum is 1. That value is generated as a third number. The third number is added with the second number. So, now it will generate the new number 1 plus 1, 2. This second number is added with the previous number. Now, the result is 3. The 3 is generated with the previous number, which is 5. 3 plus 2. Now, 5 is added with 3, which is 8. 8 is added with 5, which is 13, right. So, in this way it will generate. Now, I am taking to generate the Fibonacci series up to 10 numbers. So, we will take the series up to 10 for verification. So, 0, 1, 2, 3, 4, 5, 6, 7 number only. So, I have to generate 3 more numbers. 13 plus 8 is 21, right. 21 plus 13 is 34. 34 plus 21, 55. So, in this way we are generating, right. So, this is a microprocessor programming which will accept only the 8085. So, here I have given all the numbers in the decimal. So, I have to convert in the hexadecimal. So, here it will be 00, 01, this one is 01, this one is 02, 03, 05, 08, 13. How to read it? So, 10 is read it as 10 is A, 11 is B, 12 is C, 13 is D, 14 is E, 15 is F, right. So, 13 should be replaced with 0 D, then 21. So, 21 we couldn't write as it is. So, it should be converted into hexadecimal number 21 divided by 16. So, 1 times 16 remaining is 5. So, the value is 15. Then 34 to be converted into hexadecimal number, which is divided by 16, 32 2 times remaining 2. So, this is 22. Okay. So, up to 10 numbers only we are planning to generate the series. So, 10 numbers up to 34, right. So, these are the hexadecimal numbers we are going to generate it. First one is 0 0, 0 1, 0 1, 0 2, 0 3, 0 5, 0 8, 0 D, 1 5 and 22. Now, you get the clear concept about how to generate the Fibonacci series. Now, we will start to write the program. Here we are going to generate the series. So, I have to initialize the memory first. So, LXI H comma I have taken the address as 4500. Okay. Then next I have to initialize the counter, how many numbers I want to add it. That is a 8-bit data. So, I will use the instruction MVI D comma 10 should be initialized with the hexadecimal number 0AH. So, I have initialized the memory location 4500, then the counter value was 0A. Now, I have planned to initialize the two value 0 0 and 0 1 in B and C register. MVI B comma 0 0 H, MVI C comma 0 1 H. Okay. Then, so all initialization value is over. Now, what I have to do? I have to generate the series. So, first value should be 0. So, I want to move the B value into memory, which is 4500. So, I am using the instruction move M comma B, which represents the 0 0 value was moved to 4500. Okay. So, first value is loaded. Then what I have to do? I have to increase the memory location to store the next value. So, I am by using the INX instruction, I increase the memory location. Now, the location become 4501. At the same time, one of the series is generated. So, I have to decrease the counter DCRD as 9, right. So, what is the next number? Is the next value which is in the C register. So, I will move M comma C. So, what is the meaning of that? In 4501, the value C register value 01 is stored. So, in the series, the first value is 00 is moved, 4500, the first value 0 is moved, now 4501, the new value which is 01 is moved. Okay. Now, what I have to do? I have to increase the memory location to store the next value. Now, I am in 4502, then decrease the D register as 08. So, initially this is a value, D register value was 0A, then 09. Now, it become 08. What is the third value? I cannot move like initial values, right. So, now I have to think the logic how to store the values or how to generate the remaining values. So, the concept of Fibonacci series is sum of the previous two values. So, current value is 01 should be added with the previous value. So, I will add. So, the previous value I want to move to accumulator, move A comma B, that is for the accumulator the value 00 is moved. Then what I have to do? 00 should be added with 01, right. So, add C. So, add C means the 01 is added with 00, now the accumulator value is 01, the third value which is in the accumulator. Now, I want to store the data into the memory. So, move M comma A. So, by using this, what is the current location which is 4502. So, now the sum of the value 01 will be loaded here. Okay. So, now next I have to call the next data. So, before that the current value 01 should be added with the previous value. So, for that I want to rearrange these values. So, I will write these steps it again. So, first two data is already loaded, 4501 is with 0 1. Now, I am in 4502. The counter value was initially at 0A, then 09, now at 08. Now, I have to use the logic how to add the numbers. So, move A comma B. So, the first data 0 is moved to accumulator, then I am using add C. So, 0 0 is added with 0 1, the result is 0 1. Okay. So, I want to store this value into M. So, the current accumulator value is moved to memory. So, that value is 0 1, right. Now, I want to add this current value with the previous one. So, for that I am using the swapping, that is move B comma C. The previous value C is loaded in the B, then move C comma A, the result value is moved to accumulator. Now, I am increasing the location INX H. So, now it become 4503, then decreasing the counter DCR D. So, it becomes 07. So, till it reaches 0, I want to repeat the process with the addition. Okay. Okay. So, what is the B value? B value is 0 1. So, the 0 1 is moved to accumulator, then C value is previous resultant value which is 0 1 in the C register. So, by adding these two you get the value 0 2. Okay. So, here after adding that you have a 0 2, now the 0 2 is moved to the memory. So, 0 2 is moved to memory. Then I am moving the C register value which is 0 1 to B register. So, now B register value is 0 1, C register value is accumulator value which is 0 2, right. Then increase the memory location 4504, decrease the counter value as 0 6, it not reach 0. So, now move to this instruction. So, 0 1 is moved to accumulator, add C. So, 1 plus 2 is added which is 3, right. So, 0 3 which is moved to the memory. So, 0 3 is stored. Now, I temporarily stored the C value which is 0 2. So, now 0 2 is moved to B, the accumulator value 0 3 is moved to C register, right. The next iteration. Now, increase the memory location which is 4505, decrease the counter as 0 5. So, I have increased the location, but I did not store the resultant value, right. So, the D register is not 0. So, move to the loop. Now, what is the B value? 0 2, that is moved to accumulator, C value is 0 3. So, both are added here. So, 2 plus 3 is 5. So, 5 which is in the accumulator now move to the memory, 0 5 is moved to the memory location. Now, again I am storing the C value which is 0 3 is moved to B register, the resultant accumulator value 0 5 is moved to the C register. Increase the location 4506, decrease the counter as 0 4, it not reach 0. So, again I have to add the number. So, now the B value which is 0 3 is moved to accumulator, C value is 0 5. So, 3 plus 5 is 8. So, 8 will move to the memory which is in the accumulator 0 8. Again I am moving here as 0 5, here as 0 8, right, the new value. Then increase the location 4507, here the counter value is decreased as 0 3, it is not reached 0. So, again I have to add the B value is moved to accumulator, C value which is 0 8 is in the C register, both are added, 5 plus 8 is 13, 13 equivalent is 0 D which will be moved from accumulator to memory 0 D, right. Now, the C value which is the previous value, right, move to B register, accumulator value which is 0 D is moved. to C register. Now increase the memory location 4508, decrease the counter as 02, it is not reached 0. So, again I have to go for the loop process for adding 08, move to accumulator 08 which is in the C register is added. So, 13 plus 8 21, 21 equivalent of hexadecimal is 15. So, now the 15 is loaded in the 4508. Okay. So, after that I have to move 08 to the B register, the result 15 to the C register. Now, increase the location 4509, right, then decrease the counter which is 01. It is not reached 0. So, again I have to start the process. The 08 is moved to accumulator, 15 is added with the accumulator which is in the C register. So, 15 is added with the 0D, that is 0D represents 13, 15 represents 21. So, 21 plus 13 is added, the result is 22, right. So, the sum of the value 22 is stored here, right. Now, the C value, here the C value 15 is moved to B register, the resultant accumulator value 22 is moved to the C register. Now, we increase the memory location 450A, then decrease the counter which is reached 0, right. So, after reaching 0 it will jump from the loop, so it will exit, right. So, after exiting from the loop we have to think of any other process. Usually we are storing the data, but here for every process the data is stored in the location. So, simply you use halt. So, by halt you are terminating the main program. So, now you have to convert this program into opcode and type it. After that, after executing you have to take 4500 and check whether the numbers or the series Fibonacci series generated from 4500 to 4509. Now, convert into opcode. So, this is a 3 byte instruction. I will start the program at 4200. It will take a 3 address. So, in 4200 I have to write the opcode for LXIH which is 22, then lower byte address 00, then 45. Next address is 4200 and 0, 1, 2, so 3. The opcode for MVID is 16, then 0A. Next one is MVIB 4205. MVIB opcode is 05, the value is 00 operand. The next address is 4207. MVIC opcode is 0E, operand is 01. Then I have to write 4209, 8 and 9. For 9 the opcode for move M comma A is 70. 420A, the INX opcode is 23. 420B DCRD opcode is 15. 420C, the opcode for move M comma C 71. Then 420D, the opcode for INX is 23. 420E, opcode for DCRD is 15. Next address is 420, previous address is 0E. Now you have to start with F. In F you have to give move A comma B. Move A comma B is 78. This is a single byte instruction, single address. The opcode for move A comma B is 78, which is stored in 420F. The next address is 4210. Here you have to give add C opcode which is 81. Then 4211, which the opcode is 77. 4212, move B comma C 41. Next address is 4213, move C comma A 4F. then 4214 which is INXH 23. 4215, these all are single byte instructions. So, single address we are reserving for the byte 15, then 4216, jump on no 0, jump on no 0 is C2. Now, we have to give the address where to switch over. So, here I have to switch over. So, 0F42, okay, first lower byte then higher byte, then next address is 6789. Here I have to give the halt address which is 76. So, this way you have to convert the program into opcode. Now, we will check how to enter this program in the kit. Now, we will execute Fibonacci series program. I will take the address to type the program as 4200. Okay. So, first I will initialize the memory location where to generate. So, LXIH 21 045. Then I initialize the counter, that is 1A, 10 numbers I want. So, MBA D, 0A 160A. Then initialize the first value in B register as 0, then second data in C register which is 0E opcode is then 1. Okay. Now, move the first data to memory, then increase the location, decrease the counter, then move the second data, increase the memory, decrease the counter, then move A comma B is 78, then add C is 81. So, after adding we have to store the result into the memory by giving the opcode 77. Now, interchange the data for the current data with the previous data to be added. So, interchange, then increase the location, decrease the counter, continue this process till the counter reach 0. So, to where it will switch over 0F42, then stop the program. So, before executing take the program and check it, because the typing work is only 5 minutes, how you are thinking or writing in the logic, that is difficult. So, 21 045 05, sorry, MBAD 160A 050 0E01 70 23 15, then 71 23 15, then 78 81 77 79 4E 23 15 C2 0F42 76. Go 4200, execute it, reset sub 4500. This is the resultant area. So, what is the Fibonacci series? So, already we have generated, right. So, before seeing the result, we have to recollect what is the exact answer. So, by knowing the answer, it is an easy way to check. Instead of copying from there, we have to check whether our own answer come or not. So, first value is 0 1, right. So, 0, first I have initialized the value 0, then 1 is initialized, then these two values are added, then 1. So, now check the result after executing. So, take the resultant sub 4500. So, our expected result is first initialized as initial value 0, then 1, these two values are added, 0 plus 1 is 1, then the current value with the previous value 2, 2 plus 1 3, 3 plus 2 5, 5 plus 3 8, 8 plus 5 13. So, 13 equivalent is D, 13 plus 8 is 21, its equivalent is 1 5, The next number 21 plus 13, right? 34, its equivalent is 22. Suppose if you want to generate up to 15 numbers, just to change the counter value by taking the program 4200. So, this is a memory location where to generate the series. This is a counter value. Instead of 0A, I will give it as 0F. So, it automatically read the values till 15. So, go 4200, execute, reset, sub 4500, next 0, 1, 1, 2, 3, 5, 8, D 15, 22, 37, 59, 90, E9, 79, right. So, 0 to E 15 numbers we have read in the Fibonacci series. So, the same program by changing the counter value you can use more number of series. You can generate more numbers in the series. In today's episode, we have discussed how to generate the Fibonacci series. In the Fibonacci series, up to 10 numbers we have discussed. So, first we are initializing the number 0 and 1, then the sum of two numbers continuously we are generating, right. The current value is added with the previous value. That is the logic in the Fibonacci series to generate the series. What is the meaning of move M, B instruction? How many bytes in STA 4300 H instruction? What is the need of HLT instruction? Thank you.